Hello, I'm Cameron Martis, UTA for ATM101. Here we are out in the field getting ready to do the Unit 7 snow lab. We're looking at the site that we have chosen in which to dig the snowbank. Notice that there's a few trees around. The ground is slightly disturbed in some places, but directly in front of us we're looking at a fairly clean, apparently undisturbed snowbank. Time is about 2 o'clock on January the 10th, 2012. We're located to the back of the Reichart building and the University of Alaska Museum in a field in between both of them. Now we have cleared away the snowbank and cut a nice cross section of the snow.
Hello, this is Richard Collins, your instructor in ATM101 Weather and Climate of Alaska at the University of Alaska Fairbanks. I'm out in the snow today to give Cameron a hand to set up this video, so he's the guy behind the camera and you'll see me doing the bits and pieces as we go forward captured in the video. The first step is to record the depth of the snow in the snowbank. Holding our tape measure against the base, we see that the snow is between 15 and 15.5 inches deep today. Okay. As we look closely at the snowpack, we see a variety of structure. You see layers, like you see them in geological formations, just like the Grand Canyon, and that represents where there was different snowfalls, most recently in about the top inch of snow, and then more deeply, 2 or 3 inches down. What I want to highlight, though, is the different structure of the snow. At about 16 to 13 inches, we see a layer of fine snow at the top, the surface layer of snow. We see an intermediate layer of rougher snow from 13 to about 7. And then we see a roughest layer of snow from the ground up to 7 inches. And so what I want to do today is I would identify that we'll be working with the top layer of snow and the base layer of snow, which is where we'll take our samples today and make our temperature measurements. Now I'm going to do a manual snow hardness test of the 3 layers of snow that we've identified. Starting at the top, I start with my fist and try and push my fist into the snow, and as you can see it goes relatively easy into the snow with some small resistance. As I go to the middle layer of snow that we've identified, I actually have slightly more resistance. My fist still goes in, but if I go to 4 fingers, it goes in much smoother, about equally hard as the fist went into the top level of snow. So in terms of snow hardness, the hardness of a fist and the hardness of my fingers compares the 2 levels of the snow so far. In the lowest snow, I cannot easily push my fist in. The snow is very icy, if you will, at this level. I go to 4 fingers and you can hear the snow cracking, and I'm pushing with a similar hardness to force to what I did earlier, and I've got resistance. I go to 2 fingers and I penetrate the snow at about the same resistance I did in the other layers. So in terms of snow hardness on this particular day, the manual test would say that I have a hardness, I am fist hard here. For a similar level of force, I'm 4 fingers hard here, and for a similar force, I'm 2 fingers. Maybe you might feel it's 1 finger going in, but for your particular snowbank. Now I'm taking a sample of the snow from the upper level in the snowbank, and I'm going to pour it out on top of our 1mm grid graph paper that was provided as part of the lab today. We've placed our snow sample on the grid paper, and as you can see we have these fluffy little structures called dendrites. They look like little snowflakes themselves. They're slightly glued together, and as I break them apart it's really hard to see any individual structure. Beyond that, maybe there's little columns there, but the individual crystals it's hard to see. And so at this point I'd say that we have dendrites, individual dendrites, as I break them apart, maybe at the scale of about 1 millimeter or so. Now I'm taking a sample from the bottom layer that we've identified in the snow. Much crunchier, much harder. I'm breaking out some snow softly. I'm picking it up in the spoon. And I'm now putting this back out on our 1mm grid graph paper provided with the class. Here we see the base layer sample of snow that we've taken, and you can see the crystal structures are much larger and they're much more crystalline, like chunks of salt. This is an example of sugar snow, or large or depth hoar, where crystals may have grown during the winter at the base of the snowpack, but you can see the structure is that process is reflected in a structure that's very different. The crystals are much larger, maybe 2 to 5 to 10 millimeters, the individual structures as we break them apart.